added and subtracted polynomials, and now we're going to multiply polynomials. We're going to start out first by multiplying binomials. And we're going to use a method called FOIL. It's actually just a form of the distributive property. And what we're going to do is we're going to take the first, so we have two binomials, we're going to take the first terms and multiply those together. So that's where we get the idea of first terms. So if I multiply those terms together, I get 8x squared. And then we're going to multiply the outer terms. So we're going to take 4x times 4. So that would be 16x, and then we're going to multiply the inner terms. So that would be plus 6x, and then we're going to multiply last terms. Whoops, did that again. Which would be plus 12. And then we collect like terms and simplify our answer. So we have 8x squared plus 22x plus 12. So the method is you take your first terms in each binomial, multiply those together, then outer terms, inner terms, and last terms. And you're also going to be multiplying a binomial times a trinomial. And what we're going to do is multiply the first term in the binomial times all three terms in the trinomial. So we do 3x times 4x squared, and we get 12x cubed. Then 3x times the negative 2x, and that gives us negative 6x squared. And then 3x times 3, which is 9x. Now you go back and do the same with the second term, the positive 2. 2 times 4x is 8x squared. 2 times negative 2x is negative 4x. And 2 times 3 is 6. Simplify, collect like terms. 12x cubed, there's only one of those terms. Negative 6x squared plus 8x squared is positive 2x squared. And 9x and negative 4x add up to 5x, and then plus 6. At this time, get your papers ready, and I believe 2 sheets should be enough, and then turn to page 162. So problem number 10, copy the problem down. We have n plus 7 times n plus 5. So first term would be n times 5, n times n, which is n squared. Outer term, n times 5, which is 5n. Inner term, 7 times n, 7n, and last, 7 times 5, 35. So you end up with 4 terms when you use FOIL. And then simplify, collect the like terms. So we have n squared plus 12n, because the 5n and 7n make 12n, plus 35. And that's your answer. Problem number 12, you have r minus 3 times r plus 6. First terms, r times r is r squared. Outer term, plus 6r. Inner term, negative 3r. And last terms, negative 18. Collecting like terms, we get r squared plus 3r minus 18. Problem number 14, copy it down. You have 3a minus 2 times a minus 3. Using FOIL, first terms, 3a times a is 3a squared. Outer term, 3a times the negative 3 is negative 9a. Inner term, negative 2 times a, negative 2a. And last term's negative 2 times negative 3 is positive 6. Simplifying, collecting like terms, we have 3a squared minus 11a plus 6. Problem number 16, you have 5k plus 2 times 2k minus 3. First terms, 5k times 2k is 10k squared. Outer term, 5k times negative 3, negative 15k. Inner term, positive 2 times 2k is plus 4k. And last, positive 2 times negative 3 is negative 6. Collecting like terms, we have 10k squared minus 11k minus 6. Number 18, you have 3x plus 7 times 3x minus 7. First terms, 3x times 3x is 9x squared. Outer term, 3x times negative 7 is negative 21x. Inner term, positive 7 times 3x is positive 21x. And last term, 7 times negative 7 is negative 49. Simplifying, collecting like terms, the negative 21x and the positive 21x are opposites, so they make 0 and drop out. So we get 9x squared minus 49. And you'll learn later that that's a special product where the two terms in the middle drop out. Number 20, we have a binomial x plus 3, a binomial times a trinomial, x squared plus 2x plus 4. So we're going to end up with 6 terms. And we'll take x times the 3 terms and then go back and do 3. So 2 times 3, we'll get 6 terms altogether. So multiplying first by x, we get x to the cubed. Next term plus 2x squared. And then the third term plus 4x. And we go back and multiply by the 3. We get 3x squared, positive. 3 times the 2x is plus 6x. And then finally 3 times 4 is plus 12. Simplifying, we have x cubed, the 2x squared and the 3x squared make 5x squared. The 4x and the 6x plus 10x, and then bring down the 12. Problem 22, we have y minus 5 times the quantity y squared minus 3y minus 7. Taking y times all 3 terms, we get y cubed minus 3y squared minus 7y. Now multiplying by the negative 5, we get negative 5y squared plus 15y, negative 5 times negative 3 is positive, and then plus 35, negative 5 times negative 7. Simplifying, we get y cubed, that should have been 3y squared, minus 8y squared, negative 7y plus 15y is positive 8y, and then bring down the 35. Problem number 24, you have 3s plus 2 times 2s squared minus 2s plus 1. Taking the first term times all three of the second trinomial, we get 6s cubed minus 6s squared plus 3s. Going back and multiplying by the 2 now, 2 times 2s squared is 4s squared minus 4s, and then the last two terms plus 2. Simplifying, collecting like terms, we get 6s cubed minus 2s squared minus s plus 2. (26) You have 2n minus 5 times the quantity 2n squared minus 3n minus 2. 2n times the trinomial, we get 4n cubed minus 6n squared minus 4n. Now multiply by the negative 5, we get negative 10n squared plus 15n plus 10. Simplifying, collecting like terms, 4n cubed minus 16n squared plus 11n plus 10. Numbers 27 and 28. In each of the following figures, a rectangle has been divided into 4 smaller rectangles. The first part of the problem, find the sum of the areas of the 4 smaller rectangles. Then go back and find the product of the length and the width of the original large rectangle and compare your answers to A and B. So 28, part A, finding the sum of the areas of the 4 smaller rectangles. So we have A times C, which would be AC, plus B times C, BC, plus A times D, AD, the yellow one, and then the blue one would be B times D. Now if we take the area of the larger rectangle and find its length is A plus B, and we're going to times it by C plus D. And we would use FOIL, and we would get A times C first term, outer term A times D, inner term B times C, and last term B times D. And if we compare the two of them, we can see they are the same. You got AC and AC, BC and BC, AD, AD, BD, BD. So they're the same. And that will happen with 27 when you do that. Now we drop down to 37 through 40. 37, copy the problem down. You have x plus 2, 38. You have x minus 3 times x plus 7 minus x plus 1 times x plus 5 equals 0. So using FOIL on the first one, pair of binomials, we get x squared, outer term, plus 7x, inner term, negative 3x, last, negative 21. On the second one, you're going to have to be careful with the minus sign. If we go ahead and use FOIL first, and then take the opposite of everything, as we're subtracting one polynomial from the other, we get x squared plus 5x, outer terms, inner term x, and last 5. Simplifying, this is x squared plus 4x minus 21 and this is minus the quantity x squared plus 6x plus 5. Now take the opposite of everything in that second polynomial, and we get x squared plus 4x minus 21 minus x squared minus 6x minus 5. Collecting like terms, the x squares are opposites. They make 0 and gone. 4x and negative 6x is negative 2x. And a negative 21 and a negative 5 is negative 26. Equals 0, solve for x, add 26 to both sides. And we get negative 2x equals 26, divide by negative 2, and x equals negative 13. And problem number 40. You have 3x plus 5 times the quantity 2x minus 3 equals x minus 1 times the quantity 6x plus 5. Using FOIL, we get 6x squared, outer term negative 9x, inner term plus 10x, last term negative 15. On the right side of the equal sign, first term, you get 6x squared, outer plus 5x, inner negative 6x, and last negative 5. Simplifying, we get 6x squared plus x minus 15 equals 6x squared minus x minus 5. Getting the variables on one side, start with the one with the highest degree, 6x squared, we subtract that from both sides, and that goes out. So now we have x minus 15 equals the opposite of x minus 5. Get the x's on one side, add x to both sides. So now 2x minus 15 equals negative 5. Solve for x, add 15. And we get 2x equals 10. Divide by 2. And the answer, solution for x is 5. And that concludes the assignment.